Hello, welcome back. Today we're going to go over the quiz first, which is part of the homework, and then we'll also go over the homework. Even if you did well on it, which most people did, there's probably going to be a lot for you to learn from it. And if you haven't submitted the homework yet, this is your final call, so please do so before I start going over it here, or you're going to get nothing for it, unfortunately. So submit if you have not. Okay, let's check out the quiz first. For the quiz, you just have to assume that everything works as it was described in the homework's implementation, which you should be familiar with because you got to do it. But this is something that you're going to have to do pretty commonly. Just see some code and the documentation for it and just assume that it works the way that you're told that it works. Very rarely are you going to read the source code for every single thing that you run into, and I'm sure that none of you have gone in and read the source code for substring, for example, or one of the other different Java APIs that are built in. You've probably never looked into those, and rightly so, because 99% of the time you don't have to. Okay, so for the quiz, we have a color called boring and a color called less boring. And we blended them together, so boring.blend. We have a color called boring, and then we blended it with a color called 200-250, which remained unnamed. I just declared it once and then didn't assign it into a variable. And that color, the result of the blend, is less boring. So less boring is going to end up being halfway between 100 and 200, which is 150, halfway between 100 and 0, which is 50, and halfway between 150 and 250, which is 200. So it's going to end up being 150, 50, 200, just based on the simple math there. But then we set the green value to 0, so it ends up being 150, 0, 200. And then we lightened it, which is multiplying by 0.2, so making it 20% bigger. Now I'm bad at math too, so if I was you, I'd plug it into a calculator. But I can do 100 times 120%, 150 times 120% in my head. I can do that. So 20% of 100 is 20. Half of that is 10. 20 plus 10 is 30. That's some Common Core math right there. That gives you 150 plus 30 is 180. If you didn't get that, then maybe you were educated properly. 200 times 120%, I can do that too. 10% or 20% of 200 is 20 plus 20 is 40, so it's 240. And this is still a valid color. All right, semi-boring then gets blended. It's a blend of the original boring, which is 100, 100, 150. So it's 100, 100, 150 blended with our color that we just made, the less boring one, 180, 0, 240. So that was a little bit tougher math, especially the halfway point between 240 and 150. But the other two values are simple. So halfway between 100 and 180 is 140. Halfway between 150 is obviously 50. And then our halfway point between 240 and 150 is 195, or you could have plugged it into a calculator. Okay, and then it just asked you to tell me what the RGB values of semi-boring were at the end there, so it would be those three values. Let me look into it and see how everybody did real quick, so you can see the average stats and everything. I'd like everybody to know where they're at, statistically speaking. Okay, so most people, it looks like, didn't get it, but I gave 205 as a correct answer on the third one because the first time I tried to do the math in my head, I got 205, but it looks like no one's as dumb as me, and the people who did it actually got the right answer, so good. Quite a few people, it looks like, were only able to get the easier math problem, the 50, and then they did the arithmetic wrong on the other one, so it looks like some people are bad at arithmetic or didn't want to whip out the calculator for a 5-minute task. Remember, your internet browser is a calculator. If you're taking the homework assignment, then you probably have your internet browser open. So it doesn't hurt you to open another tab and go 240 plus 150 in parentheses divided by 2. Of course, don't do it in the same tab as your quiz for obvious reasons. Okay. Any questions on just the quiz portion? All right, let's move on to the actual homework review. For this, I'm going to make a, not going to save those comments, I'm going to make a new package. Call it Homework 2 Solution. I'm going to make the driver class, and then I'm going to copy the stuff that I gave you in there as your starter. Actually, I'll just set up my 3 classes first. So I've made the driver with the main method, and then I'm going to make that CustomColor class, and then I'm going to make that palette class. Palette's a tough one to spell. I think it's 2 T's. Or I might have spelled it wrong everywhere. It's a possibility too. Okay, this is the driver that came with it, so I'm going to copy that, including the main method there. And just paste that right in there. Now, when you paste from another project, and I've seen a couple of people run into this when they've been trying to use some of the stuff they learned in class in order to complete their homework. Sometimes Eclipse thinks it's too clever for its own good, and it'll pull in these imports from the other project. You're not going to want to do that, obviously. You're not going to want to import classes from your class examples or anything for your homework, so delete those. Those are usually a mistake. That's Eclipse just thinking, well, okay, you pasted some stuff that has to do with this class, so you must have wanted to import that class into this project too. Which is a reasonable assumption to make. Normally that would probably be true if you were actually working on an application and you went and pasted in some other project. You probably want to import it, but that's not going to be the case for homework. So if you see those imports pop up, delete those. Especially leads to problems if you have 2 tasks with the same classes with the same names. All right, the other problem I saw a lot of people run into was obviously when you paste the main method in, everything is broken, right? Because you don't have anything yet. So of course everything's red underlined and nothing works. And it's very hard to work on your code and test it when everything is red underlined. So how do you get rid of everything quickly? I saw a lot of people still doing this, which is they do the /*, and then they kind of find the bottom, and then they do the star on the other side. That's fine, but then to undo it, you kind of have to hunt down the /*. Like, where is it? Okay, it's at the top of the green stuff and the bottom of the green stuff. So I get rid of it there, and get rid of it there. The easiest way to comment out a big block of code is to highlight everything that you want to get rid of and hit Control/. And that comments everything out into a block. And then to undo it is the same thing. So you highlight everything you want to uncomment and you hit Control/ again. In addition to being much faster, this Control/ way also allows you to selectively uncomment out blocks. So let's say I just wanted to bring that back. I could just bring that back quickly. If I just wanted to bring this back, I could just bring this back quickly. So I saw some people run into parts where, for example, they made the palettes blank constructor before they made the white-black one. Well, if you want to test the blank one, you either got to move it or something in order to get it above the white-black one where you have the error, or you could just comment out the whole block and uncomment out the one that you have working so that you can test it. So Control/, definitely the way to go for commenting out big blocks quickly. Let's see what everybody's preferred method is. Actually, I'm going to take a poll. Preferred method of commenting out big blocks. I delete them. Like a real professional. add something else in there. Maybe somebody's going to come up with a better alternative. Okay, so with that in mind, I commented out everything except the topmost part, because that's the first part I'm going to do. And you could do it manually. I would suggest you do it manually, but I guess I want to point out another tool that's available here, which is to let Eclipse automatically generate missing constructors for you. So the first thing that Eclipse recommends you to do in order to fix this is remove arguments to match custom color. So remember, if you don't specify a constructor, and of course we didn't because custom color is blank, you get this by default. You get the custom color blank constructor with nothing in it. That's what you get by default if you don't specify anything. It's just hidden, basically. But that's not what we want, obviously. So that first recommendation, to remove arguments to match the default constructor, that's not a good idea, because then this is a color with no properties. That's not what we want. That second recommendation, to create a constructor in custom color, is right on the money. And if we click that recommendation, it's going to take us to custom color, and it'll make us a constructor that takes 3 integers. The reason I don't usually do this is, first of all, this isn't really that hard to do manually. Second of all, it gives you the default variable names, which just follows the alphabet, I, J, K, L, M, N, O, P or something. And those obviously aren't very good variable names, so I would rather have red, green, and blue here. And by the time I'm done fixing it, you know, it's already taken me more time than if I had just made it myself in the first place. But if you want to let the tools do everything for you, there is definitely a way to do that. The other thing I've seen a lot of people doing is they will use the tool, they'll do the auto-generated stuff, and then they'll write all their code and blah, 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 and they'll leave this thing in there because they don't know what it is and they're afraid to delete it. This is Eclipse telling you that this was automatically generated and nothing has been done with it yet. So once you address that and actually do something, you should get rid of it. So it's basically your warning that, hey, this was automatically generated and you need to go manually review it and add some stuff to it. So just make sure that you delete those afterwards. You don't want to see a bunch of to-do stubs in methods that you've actually worked on. Alright, so custom color was supposed to have 3 fields, integer fields, and remember you can declare them all in one line. I don't think I saw anybody do this convenient one-line declaration in this case. Of course, there's nothing wrong with declaring them all on their own line, just in this case they're the same kind of value, and it just seems to make sense to me, so I'm going to do that. And then, of course, in the constructor, we need to link together the red that you got with the red field at the top, the green you got with the blue field at the top. So again, if you're not familiar with how the constructor works, we take 3 inputs as arguments here, the red, the green, and the blue. And we have 3 fields at the top, as it said to do in the homework. You got to make a red, green, and a blue field. And we're going to set the fields, red, green, and blue, to these values, which means that we're going to have to use that keyword this in order to differentiate the field from the local variable that has the same name. There are actually programming languages out there that just don't let you use the same name to avoid this kind of ambiguity. And Java isn't one of those, and this is closer to the standard practice than the naming it something different variant. Now, of course, if we had named them something different, we could have omitted the keyword this, because remember, it is inferred if you name it something different. So I could have done that. And when you do that, you'll notice red, green, and blue are still highlighted in teal for me. If you're using the light mode skin, then you won't notice the difference because your local variables and the fields are the same color, which is a little unfortunate. But on the dark mode skin or on any skin where you've changed the colors, you'll see that those 3 variables are still in teal. That means that they refer to fields rather than to local variables. They refer to fields or instance variables or whatever you want to call them. And it means that the keyword this was inferred. So it's there, it's just not visible to save us some typing space. So these statements are identical as well. I'm going to go back to the more standard version where I use the same variable names and the keyword this, as I find this easier to understand. Now there was another requirement that you had to do. You had to make sure that none of them exceeded 255 or were smaller than 0, otherwise print an error message. So that's pretty straightforward. I think everybody got that. So if red is less than 0. Some people said less than or equal to, which is wrong because 0 is a valid color value. Or red is greater than 255. Again, not greater than or equal to, because 255 is a valid color value. Or green is less than 0. Or green is greater than 255. Or blue is less than 0. Or blue is greater than 255. And then we wanted to print an error here. I'm going to use system.error.println because it prints in red. So not a valid color. And then in order to help you better identify what the problem is, I'm going to print out the color that it is. And to facilitate that, I'm going to write my toString method first so that I can better print things to the console. And this is a good practice in general, is to write the method that allows you to debug better and actually see your stuff in the console before you move on to the meat of it. So if you didn't write your toString method first, then anytime you ran into a problem, you would have to like manually print out the colors or something. If you wrote your toString method first, then you can easily print out anytime you have an issue. So I'm going to leave myself a little note to do add color.toString to the error printout, and I'll come back to that when I'm done with it. So the toString method returns a string. It's a public method. It overrides the existing toString method. I'm going to have a string out, as I normally do, and then I'll return it. Okay. And you see that it's an override because you get the little triangle there. So what am I going to set my output to? Well, I can actually do it all in one line. It's pretty straightforward. I'm going to say color width R plus red, G plus green, and B plus blue, RGB. I've put some spaces between those. This is a hard exercise to master the proper spacing of things inside of a multi-variable print statement like this. Really, we didn't even need the string out equals here. I probably could have just shortened this to one line and just done that. So that would probably be the easiest way to do it, the most concise. But this exercise, the act of reducing lines to the minimum, is a practice some people refer to as code golf. Golf, of course, being a sport where you try to get the ball into the hole with the fewest strokes possible. Code golf being a reference to trying to get your code done with the fewest lines possible. Sometimes it's helpful because sometimes shorter is easier to understand. I think this case is one of those. Other times it's not that helpful because shorter is harder to understand. So don't worry about making your code as short as possible, and worry about making it as understandable as possible. When you see a long block you feel that you could make shorter and more understandable, then do it. If you have a long block you feel like you could make shorter and less understandable, then don't do it. Okay. So I said not a valid color, and then I'm going to print out the toString value there. So I'll print out this dot toString there. I can get rid of my to-do because I've done it. And I should probably leave my comments here now. So it creates a new, I'm just going to say color instead of custom color for brevity, with the specified red, green, and blue values. Prints an error if any values are smaller than 0 or larger than 255, but proceeds anyways, which is an important note to make here. We'll see why in a second. Prints this color in the form color with our red, G, green, B, blue, where red, green, and blue are the color values, respectively. Okay, so all of those are fine. I think I asked you to print slightly differently on the homework assignment. I gave you a format, but I'm not going to match the format exactly. It doesn't matter. And I probably would knock you if you printed a different format too. So now it's time to test this. That's the first thing you should do. I gave you this long driver to test things out, but it's actually missing a couple of the tests that you might want to do along the way. So let me print out first red, for example, and let's see if red prints out correctly. Okay, cool. Red printed out correctly. Let's try another test. Let's see what happens when I make one of the colors invalid. Let's do it for red. Let's change it to 27000, which is not a valid color. So not a valid color, a color with our 270. Okay, perfect. But then it still goes on and prints it anyway. Okay, let's try -5, the other direction for validity. So that also didn't work, but it still goes on and sets it to -5 anyway. So with that in mind, let's look at what Java actually does. So let's use Java's real color class. There is a color class built into Java. So I'll call this real red. Now it takes 3 integer values, just like the custom color that I had you design does. I'm going to have to import color because it's not built in. It's built into the standard library, but you have to import it to use it. So it'll have a red underline when you first attempt it, and then you will go to the quick fixer and say import, and it will import it for you. You'll see it at the top. It's my only import right now, java.auth.color. Let's read the documentation for it a little. So it's taking 3 integer arguments, creates an opaque sRGB color with the specified red, green, and blue values. What does it mean by opaque? Well, there's a fourth value that you can specify called alpha, if anyone's familiar with painting programs and stuff, which is the transparency of the color. And 255 means that it's not transparent at all. It's completely opaque. And so they tell you here that it's opaque, and then they say again at the end, alpha is defaulted to 255. So our custom color doesn't even bother with alpha. We just bother with the color. The Java built-in color also supports that fourth value, the alpha. And if you just give it 3 color values, it'll default the alpha to 255. The actual color used in rendering depends on finding the best match given the color space available for a given output device, basically telling you that you might not get exactly what you think it looks like, I guess. And it has an exception if R, G, or B are outside the range 0 to 255, inclusive, which is a nice way of saying that 0 and 255 are viable options. So inclusive and exclusive are always shorthand for telling you that the values given are acceptable or not. Get green, get blue, and get red are also referenced here, as well as get RGB as methods that you must also see. But let's have a look at what happens when I make a real red and then print it to the console. So I'll print real red to string, and we'll see what Java's colors print like instead. There we go. So it's very similar. It prints the object name first, so that there's no ambiguity. Mine's a little bit more ambiguous. I just said color. It could refer to different color objects, right? There might be more than one. There's 2 in this program now. And they like to put their values in square brackets, but otherwise the printout is very similar. They put some commas between them, they put some equals, but it's very similar to what you made in your assignment. Let's see what happens if we try to give it a value that is out of bounds, so larger than 255. You get an exception, and it does not continue. All right, so that's a little bit different than ours. We don't crash. We don't know how to do that yet, actually. We don't know how to cause an exception. Or why that might be a useful thing to do, but that's one notable difference, is that any of the values go outside the acceptable range, and the built-in color, it will just crash, or throw an exception more accurately. And we'll learn how to deal with that quite a bit later, so for now, your way to deal with that is just don't let them go outside the typical range. What if I want to change a color value? So most people in the homework assignment set the fields to public. So if I wanted to change red dot blue, I could just change it to 50 like that. So in my custom color class, I set them all to public here. Most people did the same. They didn't use getters or setters, and I could just set red dot blue to 50. So if I ran this, I would see that my first color being printed out now has a blueness of 50. That allows you to do some bad things, though. It allows you to set it outside the range like this without any warning. So that's one problem with that. I wouldn't knock you for making them public just because the convenience here is pretty significant and because I didn't specifically ask you not to. But it is probably bad practice here. In fact, we'll see that the real color class, real red, does not give you direct access to redness like that. It does have two values called red, which is a little bit misleading, but these are static colors if you look at the type. They are not integers, they are colors, and that is actually a placeholder for this color, which gives you a really convenient thing you can do if you want any of the true colors, so red, blue, green, cyan, magenta, any of the true colors being the 255s, the 255, 255 zeros, any combination thereof, you can access those by just saying color dot, and then there's a red, a green, a blue, a cyan, a magenta, a yellow, an orange. And I think I missed one. And there's white, black too. So those are all built in, and those are just shorthand for this, so that you don't have to type those three. So that was a convenience that they added. You'll probably use this extensively when we get into using color more later. But the actual red, green, and blue fields are private, and you have to access them using a getter. So if you want to access the redness, you would have to use realRed.getRed. Let's try printing that out and seeing what we get. We get 255 for real red. What happens if you want to change one of the color values on a custom color, or on a built-in color? So some of you tried to solve parts of the homework by changing the color values as you went. Now let's look at what happens there. So is there a set red? Let's try typing set and see what we get. We get nothing. All right, how about I type red and see what I get? I get nothing. I'll only get red. So there is no way to change the colors in a Java built-in color once you've created it. So the process, if you wanted to change one of the color values in real red, would actually be to make a new color. So you would make a new color. And then let's say that you only wanted to change the blueness. You wanted to add 50 blueness like we had just done previously. You would have to do something like this. You would get the redness, the greenness, and the blueness, and add 50 to the blueness. That would be how you would increase the blueness of real red. And notice that I've just saved over the real red variable with that new color. So this is a valid expression, and it's also an expression that I used on the quiz when I did this. So this line here, the less boring dot green equals 0, real color wouldn't let you do that. But this, it very well would. Less boring equals less boring dot lighten. That would be something that you would do, and it's quite similar to this here. So let me take a quick poll and see if everybody gets what I did there to raise the blueness, and how I raised real red's blue by 50, because this is something we're going to do quite a bit down the road, change the values of existing colors. You should be familiar with it, because we will do that later. And there is no set, and you can't just plus equals or anything. There is no access to the real colors fields once you create it, aside from the getter. You can't set them or change them. And again, the word that we usually use to describe a variable like that is that it's immutable. So we say that once the color is created, it can't be changed, it can't be mutated, so it is immutable. Most people look like they get that. I'm going to leave that up for a bit. I'll call this section comparing against the real java.odd. This is again a simple way to get 25500. Another thing that I'll point out that we might use occasionally is that the built-in Java one supports another kind of constructor. It supports a constructor that takes decimal values between 0 and 1. As floats. Take a guess in either chat and tell me what you think this color is. What is the value of this color? I'm going to print it out to the console here. I'm going to get rid of these. I don't think we need them anymore. And I'll print out this real color to the console. What is the RGB value of another real color here? In either chat, if you have a guess. So I'll hold off on printing that out until we moved on. Somebody said 000. No, this is a fancy. I'll hover over the documentation for a hint. Creates an opaque sRGB color with the specified red, green, and blue values in the range 0 to 1. Alpha is defaulted to 1. The actual color used in rendering depends on finding the best match. Returns an exception if it's outside the range 0 to 1. Interesting. So what color is that? And why might we even have that? Why would you support the ability to get a color with doubles? So FID got it. It is 127, 127, 127. Well, actually, not quite. Rounded up. But you get the idea. It's 255 times 0.5. So it just multiplies the float by 255 and gives you a color with those three values. So why might you want that? It's convenient for generating a random color. So if you want to get a random color really quickly, you can do math.random, cast it as a float, because remember it gives you a double, and this doesn't take doubles. And just do that 3 times, and it gives you a random color. So you can run that. Get yourself a random color every time, so that's very convenient. And there are other reasons it comes into play, but just something that I want you to be aware of, that you can also give the real color a float. So the Java's color can also take 3 floats. It just multiplies each float by 255 to get you a color. Okay. So back to custom color, let's work on our next method. The next thing in the driver that I needed to address was the blend method. The blend method is supposed to take another color and combine this color with that one. So red.blend green gives you orange. Red blended with green would give you 127, 1270, which is not actually true orange, it's light orange. If we look at the real orange color, real orange, and print it out to the console, the real orange is actually oranger than our orange. It's 255, 200, 0. So that's what they decided true orange should be. I wonder if it tells you that. No? Okay. All right, so working on our blend method, it's going to return a custom color, and it's going to take a custom color as an argument. I saw a lot of different variable names here. I typically go with other as the placeholder variable name I'll use when I'm taking another object in and doing some stuff with it. Unless I have something more specific in mind for some reason, other is usually a pretty good placeholder. Since this is a custom color, I'm taking a different custom color, another one. Other makes sense there. And then, of course, something like C would probably be fine too in this context. Okay, so almost everybody figured out that to get the average, you would need to find the sum of their reds and then divide them, right? Pretty much everybody got this part too, that in order to access the redness of the other one, you would do other.red. There was a bit more struggle on the how do I access the redness of this color portion of it. So remember, we want to access the redness of this color, which corresponds to the red field at the top here. Of course, to access the redness of this color, we're going to say this.red. And in this context, we could have omitted the word this, again, because there is no other variable named red. There's an other.red, but that's not the same thing. So it would have inferred this from the context here. Now, red is a field of other, so it appears in the same color in that same teal. All right, so that's not to say that only fields of this object get that highlighting. All fields get that highlighting in at least this skin of Eclipse. And I don't think you can change that, actually. I don't think you can color local fields separately from non-local fields, but I might be wrong about that. If you check your settings, maybe there is one. Average green, other.green plus this.green, and average blue, other.blue, this.blue. And then, of course, you want to return a new custom color with these values. A couple people made the mistake of modifying either this color or the other color's red values. We want to keep those the same, so you don't modify the values of either this color or the other one. We're going to be returning a new custom color that uses those new values. Average red, average green, and average blue. This was how most people structured it, this 4-line version where they computed the averages. Obviously, I forgot to divide by 2 there, so thanks for pointing that out, everybody. I'm great at doing averages. Okay, so with the dividing by 2 in mind, that's an average now, not a sum. Most people did it like this, where they had it in 4 lines. A couple people did the shorthand version, which I would prefer here. I don't think you need 3 variables. I would put them all on their own line and do something like this. I find that to be considerably easier to understand. Of course, the auto formatter breaks that completely for me, so I don't know, might turn it off, might leave it on, might make custom color shorter. This is still readable to me, so I'll probably deal with it, frankly. I prefer to have it like this because these 3 lines are pretty repetitive, and I don't think that they need to have their own variables necessarily. But up to you, of course, if you did the 4-line version. I wouldn't knock you for it at all. And if you find the 4-line version easier to read, then by all means do it that way. There are no points, again, for winning at Code Golf. Returns a color that is the average RGB values of this color and the color specified in the argument. I think that's a fair description. Alright, so let's try that out. I can now uncomment these portions and see if I have the right orangeness and redness. So my orange is 12700. That is orange-ish. And my purple is 0127127, which is purple-ish. Let me verify that those are really as purple as I think they are. Let's go. 127. If you're really astute, you'll notice it's really not not that purple. It's kind of more of a cyan. And 1270 is kind of orange, but it's really more of puke. So these aren't really accurate, but that wasn't the point of the assignment. Okay, and next on the list is Darken and Lighten. You'll notice that the real color method doesn't have anything like blend or any kind of combination. Nothing like that exists. There are no methods of real color that takes another one as an argument. An alternative to the blend method, by the way, I didn't say that it had to be structured exactly like this. So an alternative might have been to make it public static custom color blend and then take two colors as arguments, first and second. This could have been an alternative to the existing blend method, and the return would be very similar. Instead of this .red, you would take the first one for everything else. So you would take the others. Other will be second here, although again order doesn't matter because it's an average. And first will take the place of this. So what's the advantage of the static version that you could have made of blend? Nobody did this because I think the requirements said you had to do it this way, and obviously that's how I have it in the testing method. But what's the advantage of doing it this way? Why would anybody want a static blend instead of a blend like this one? Why would anybody want a static blend instead of a blend like this one? I can pretty much copy the comment here because it does the same thing. The first and second colors specified in the arguments. Why would anybody prefer the static version over the blend that we have there? Sit on it for a bit while you think. Why would anyone prefer the static variant? Yeah, the answer given in Discord is the best one. It's because you don't need an already instantiated custom color to access blend that way. And then the second, maybe less important answer is for readability purposes. This is kind of bizarre to read, and it also lends itself to a weird question. Some people asked, another orange, is this the same thing? Obviously it is, right? Red.blend green is the same thing as green.blend red. But it's weird. It's a weird format. Whereas the format CustomColor.blend red-green is a little bit more straightforward to understand. We understand that we're blending all the colors inside of it together. It's also easier to extend it in the future if we decide to take 3 or 4 colors as arguments and blend them all together. That would be an easier path to extending it, whereas it's a little awkward if you're taking 3 arguments and then 1 at the beginning. So it's mostly just a preference advantage or readability advantage. There's no compelling reason why the blend method needs to be not static here, because they serve the same purpose. You're always going to have to provide it with 2 colors. It's always going to return a new custom color. So just a design choice to consider that both of those are acceptable. Just say this would be fine too. And again, the main advantage is that you didn't need red in order to access CustomColor.blend here. Okay, next is Darken, which the real color does have a variant of. So let's look at what the darker reads like on the real one. So let's say I want to say real red equals real red.darker. Creates a new color that is a darker version of this color, applies an arbitrary scale factor to each of the 3 RGB components. Brighter and darker are inverse operations. The results of a series of invocations of these two might be inconsistent because of rounding errors. So basically, if you lighten twice and darken twice because of rounding errors, you're not going to end up with the same color. And also they tell you that the alpha is preserved. Our alpha is always 255, so we don't care. Let's look at what you get. Actually, let's print that out. So I'll print it out here. We'll do a little marker so it's easier to see. Darker red. Let's see what a darker version of red is. So red was 25500, remember? Darker red is 178,035. What is even darker red? Let's go with darker. Even darker red is 124,024. So it makes all the values smaller, except what's going on with the blue, right? It's now 16. I mean, where did we even get the blue in the first place? If we just printed out... Oh, right, I added 50 to it. Never mind. Okay, so it's making all the values smaller by some arbitrary scale, which is the same thing that we're doing. And I picked 1.2 to be that arbitrary scale. It's not 1.2 in the built-in color. It's something else, and the exact value doesn't really matter. So let's do the same thing in our custom color. Go further down here. Custom color darken. So first thing that I want to do, I'm just going to return null as a placeholder here, is a lot of people just put 1.2 as their magic number here, so they just did int new red equals red times, sorry, it was 0.8 for the darken version. They just did something like that. Right, and that's fine, but what if you wanted to change the darkening factor quickly on all of them? So let's say you got, here's your green, there's your blue, green, blue. And what if you've decided that you suddenly don't want it to be 0.8 anymore, you want it to be 0.75 or something instead? Well, then you have to go back and change them all individually. And of course, the 0.8 here is very arbitrary. It's kind of a magic number again. Magic numbers should be avoided. And let's say we also had it in the comment here, darkens everything by, and then we just have to say 0.8. And if we change all of these, then okay, we have to remember to change the comment too. So the better way to do it is to make a variable for that 0.8. And since that variable isn't going to change, it's immutable, I can make it a final. So I'll call it a final int. Finals by convention are in all uppercase separated by underscores, so I'll call it the darken factor. And it's not an int, is it? It's a float. So the darken factor is 0.8. Good time to point this out. I saw a lot of people, when they select individual variables, they do this. And then sometimes they accidentally end up doing this. And then they paste it somewhere, and oh, it has an extra space. I didn't mean to do that. So if you want to practice one really good skill for today to make you better at typing your code, practice double-clicking your variables to select them. Double-clicking your variable selects the variable quickly and without the room for error in highlighting it. And if your variable somehow spans a very long stretch, I don't know, none of these are particularly long, but let's say you want to just other, you could double-click other. If you want to just red, you could double-click red. Yes, double-click your variable. The other cool thing that happens when you double-click a variable like this, you see it highlights all the places where it's been used, so you can quickly run through your program and see all of the occurrences. So double-click your variables to select them. If one skill you pick up today, that should be it. Double-click to select them. And I always use Control-C and Control-V for copy and pasting, so Control-C to copy, Control-V to paste. Since we're already on skills, let's look at one more today. I'm not a huge fan of the outline, but I will use it when my projects get a bit longer. You're certainly free to use it right from the get-go. A lot of people find the outline very helpful. You can open the outline again if you have accidentally closed it by going to Window, Show View, Outline. So again, that's Window, show view outline to bring the outline back if you accidentally close it. If I do use it, I like to have it on the right-hand side here. Remember, you can drag windows wherever you want them, so if I wanted my console here for some reason, I can do that, and I want it here for some reason, I can do that. Drag windows wherever you want. You can also turn things into tabs, dragging them into the same window. What the outline lets you do is it lets you see all the fields and all of the finals and all of the methods and constructors in a list, and then it lets you jump to them really fast. So I want to replace my 0.8s down there in Darken with Darken Factor. So I could scroll down there and find it, but if there's a lot of stuff to scroll through, that could take me a long time. If I click on Darken in the outline, it'll take me there and highlight it, and then I know where I am very quickly. So once your project gets long and you've got a lot of methods, it can help to use the outline to navigate really fast. So I'm going to go ahead and paste my Darken Factor in there to replace 0.8. So this multiplies R, G, and B by, oh, I should say, multiplies this color's R, G, and B by 0.8 and returns the resulting color, R, G, and B values. This might be a little bit ambiguous because I said that it multiplies the values, and that might imply that it actually changes them. So think about rephrasing that kind of wording to make it clear that the original R, G, and B values don't change. And what I would do here, instead of saying 0.8, of course, is that I would link to the Darken vector at the top, which allows me to change that whenever I want, and it will now automatically update here as well as in the code. And I also might, if it is shared for all custom colors, and it is in our implementation, make it static, public static final float, because all custom colors use the same darkening factor. And the advantage to doing that is that now, when I hover over Darken's documentation and then click on Darken Factor, I can actually see the value, 0.8. Remember, you can only see the value for static finals in the hover over tooltip anyway. So that can be helpful too. All right, so I'm returning a new custom color with the new red, new green, and new blue. And once again, to make those shorter, I would probably just do it all in one line. I don't think I would make the 3 variables. If you did do this 4-line variant, again, you are welcome to it. For me, that's 3 very similar lines. I don't need 3 variables for it. I'd rather not repeat it, so I would just do those right in the declaration. But if you're uncomfortable with longer declarations like this, and the 4-line version's more readable for you, by all means. Okay, I think that's pretty straightforward, but let's test it just in case. So Darken was the first one here. See if dark purple gives us a darker purple. Well, if purple was 0, 1, 2, 7, 1, 2, 7, dark purple is smaller on all counts by 80%, so looks good. I could move on to either lighten or is lighter. I'm going to move on to lighten because it's similar. And then I'll do is lighter later. So what's the problem with using this approach on lighten? I'm going to go up and make a lighten factor and stuff. What's the problem with using the same approach I just used on lighten? So just replacing the darken values with lighten values. What's the problem with doing that? Why is this incomplete? I'll add some more to my comments while you think about it. Why is this incomplete. Quite a few people missed this part here. Why is this incomplete? Well, I haven't checked for out of bounds, right? The greater than 255 thing. Right? So when you darken a color, it can't go below 0 because you can't multiply by 80% and bring it below 0. That was something that a few people added extra. They added a check to make sure the color didn't go below 0. It can't. You can't multiply your way by 0.8 to below 0, although it certainly wouldn't knock you for checking. But in Lighten, you can do that. So here we would actually have to do those 4 lines. So int new red equals red times the lighten factor. And if the new red is greater than 255, I asked you to clamp it to 255. So it would just be equal to 255 instead. And we're going to have to do that for all 3 colors. So we'll do that for green, and we'll do that for blue. This would be new green, and I'll paste that through. This will be new blue, then I'll paste that through. And then obviously I have to change my green and my blue here. I've thrown a lot of tools at you today, so I won't show you how to make this shorter, but there is a way here as well. So remind me in a few weeks if you've never gone back to it and you want to see, there is a way to make this shorter too, and still relatively understandable. But yeah, we have to make sure that none of those exceed their maximum. Okay, there isn't a test for Lighten until further down, so I'm going to do is lighter first, and then we'll go back and test all of them. So is lighter. Is lighter is definitely the easiest of all of the methods that you had to write. The only thing that's complicated here is, again, that use of this and other in order to see who's red and who's blue and who's green you're referring to. So we wanted to see if this color's red plus this color's green plus this color's blue is greater than or smaller than, I don't even remember. What would lighter be? Lighter would be bigger? Yeah, lighter would be bigger. Bigger than other.red plus other.green plus other.blue. Let me know in either chat if I got that wrong. I think this color being bigger means that it's lighter, I think. But then we would return true. Otherwise, we'll return false. Some people prefer this syntax where they have a default return false at the end. I'm fine with that too. When there are obvious branches, like if this, then this, else, something else, I don't like this syntax much because it makes it look like return false is like a default value rather than it actually being the value that's returned because this didn't evaluate to true. So these are connected. There's a branch that's for true, a branch that's for false. I like to make that clear by including it in the else statement there. Where I use this syntax with an extra return statement is only for default returns. So if you didn't manage to get a value during the regular execution of the body, then there's some sort of default value that returns at the end. Returns true if this color is lighter than one given in the argument. False otherwise. Okay, that allows us to uncomment down to here. So is lighter than dark purple? False. Dark purple is not lighter than purple, so that makes sense. Which brings us to palette. There were supposed to be 3 constructors for palette, a blank one, 2 arguments one, and originally I intended to make one with an array. I think I included it in the assignment. Yes, I did. Okay, so you can also make one with an array. So let's do them all at once. We have a palette that takes nothing. We have a palette that takes an array of custom colors. Okay, and then we have a palette that takes two arguments, two custom colors. Custom color first and custom color last. Why did I name them first and last? Because those are actually going to be the first and the last colors in the palette, in the color array. Palette, of course, has an array of custom colors. Custom color colors. I said that you could just assume that it's length 5. This isn't great practice because, of course, it could be other lengths, but to make this assignment easier, I said that it could be length 5. That's mostly to simplify the constructor here. So we'll see what that looks like in a bit. Now the blank constructor creates a new palette that's all white. Creates a new palette that's all white. 255, 255, 255. That one's pretty straightforward. We've done it several times on other assignments. We will loop through the colors array, and we'll make a white color for all of them. Okay, that's done. And then the version that takes an array is obviously very simple. We just set the array that we've got equal to the one that was given to us. Creates a new palette using a given array of colors. And we should say should be length 5 exactly. A length 5 array of colors, if we want to get more specific about the parameter. This guy's the hard one, right? A lot of people came up with really fancy mathematical ways to do it. But, there's a trick. There is a trick. Of course, the first value in colors, index 0, just becomes the first one. And then the last value in colors, the fourth index, if it's length 5, the last index is 4. That one's going to be the last color. What about the ones in between? Well, if you're doing a spectrum of colors, so if you're going between white, yeah, that's not easy to demo. If you're going between white and black, the halfway point is all 127s. And all 127s is the average of white and black. Okay, so the average of white and black, well, we already did that. It's the blend method. So the color that's in the middle, the color at 2, is the first one blended with the last one. This is the color in the middle. And then the color on either end is that color blended with the first or blended with the last. So altogether, it ends up looking like this. You get the first color, first blended with last. Last color's on the end. Okay, and then this one is going to be last blended with that. And those are going to be first blended with the one below. There's no down caret. So colors of 1 is going to be first blended with, and then this color that we just determined. And colors of 3 is going to be last blended with, and then this color that we had just determined. And that's how you quickly create a spectrum of colors. All right, we're out of time for today, but the average color, I think, was pretty straightforward. You just added the 5 of them together and then divided by the length of the array. I think almost everybody got that one if you got the rest of it. And I guess real quick, the toString method, or the print palette method, I think I called it public void print palette. Feel free to head out if you have to. Is I equals 0 is less than colors.length I plus plus, and we're just going to call the toString value, toString method on each of the colors in order to print them out. And that will just print them all on their own line. And that should be it. Be able to uncomment the rest and run it. Just haven't done the average yet, and there we go. If you wanted to add the extra new line, like the instructions told you, you would just have an extra system that out that print line at the end there. That puts them all in their own little line. Okay. That's it for today. I will see you all next time. Don't forget to start the homework.